Hello and welcome to another episode of EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in sustainability, climate change, buildings, and urban efficiency. I'm Vic Marinich, Global Marketing Director at Danfoss, and I'm delighted to be the host of this podcast. You can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever you get your podcasts. Today, we have Bethany Seubert from Greenheck on the show to talk about dedicated outdoor air systems, or DOAS systems, and indoor air quality. Bethany is product manager for DOAS units at Greenheck. Bethany, it's an honor to have you on the show.
Thank you so much for having me, Vic.
So today we're discussing DOAS units and rooftop units and the role they play in improving indoor air quality and improving energy efficiency. But maybe let's start off with kind of the basics. Bethany, can you tell us what the differences are between a traditional rooftop unit and a DOAS unit?
Absolutely. There are definitely some key differences between these types of units. So let's just start with a traditional RTU or rooftop unit. It brings in a mix of recirculated air from the space and outside air. So typically a standard RTU can handle anywhere from 20 to 30% outside air. And then the rest of the air, 70 to 80% of that air, is recirculated from the space. So that air that's recirculated from the space has already been conditioned, but it's picked up some load from the space, right? So that RTU then conditions that mixture of 20 to 30% outside air and recirculated air to maintain a comfortable temperature and humidity level for the spaces that it's then serving. If you look at a DOAS unit, on the other hand, that's bringing in 100% outside air. So the main focus is to provide fresh ventilation air to the space, and it's decoupled so that it's focused on dehumidifying and removing the latent load to ensure the humidity levels are comfortable for you and I in a space. So primary focus, again, is to dehumidify. And then what happens is there's typically an air handler or terminal unit that is used to maintain the temperature required for that given space that's paired with that DOAS unit that's bringing in that fresh air that's dehumidified. There are so many reasons why someone might choose a traditional RTU versus a DOAS unit. So it can depend on ventilation rate requirements for that space, the type of space, number of occupants in that space, the size of that building, overall budget, different local codes and regulation requirements, how tight of temp and humidity control are needed. Maybe it's an owner or engineer's preference. So a lot of different factors go into why somebody would choose a traditional RTU or a DOAS unit and how to apply it to their building. One example I like to give is, DOAS units are very commonly used in applications such as schools, right? High concentrations of people requiring higher ventilation rates compared to if you were to think of a small store in maybe a small strip mall or a small office building. Less occupants, right? So you're going to have less ventilation area requirements based on the number of occupants and based on the size of that building. So that may be more suited for a traditional RTU. But again, there's many factors that go into play of why an RTU or a DOAS unit might be used.
Is a DOAS unit then a standalone piece of equipment, or is it part of an overall system? And then does it need to be applied with rooftops? Or if you've got, say, a bigger building where you've got chillers or maybe even VRF and so on, can you also incorporate DOAS units into those systems?
So as I mentioned, a DOAS unit's primary focus is to bring in that fresh air and to remove that latent load. So it's definitely a part of a fuller system. So the intent is really to decouple the system, have that unit take care of removing that moisture, and then have an additional air handling or terminal unit that takes care of additional sensible load from the space. If you think about it, in the middle of a hot and humid summer, the fresh air is really warm and sticky, right? So essentially, we just need to wring out that humidity and heat so people are comfortable when that fresh air is delivered into the space. The DOAS unit focuses on removing that humidity or wringing out that moisture in the air. Then it feeds directly into another device or a parallel device. That's going to be that terminal unit. That's going to take care of the sensible load. So that's making sure that we're comfortable from a temperature standpoint in the space. Those are sometimes referred to as air handlers or terminal units. They can be above the ceiling. They can be at the floor or a wall of the space. And those types of units can range depending on what type of system is being used in the facility. For example, You may use terminal water source or air source heat pumps. VRF system could be used to take care of that sensible load in the space. Chilled beam, fan coil units that may be utilizing a chiller or boiler system, a PTAC unit to maintain, again, that sensible load requirement in each of the zone. Example I like to talk about for this is if you think about a hotel room. We've all stayed in hotel rooms, right? In many cases, there's going to be a unit near the wall that's below the window. That unit's purpose is to maintain the space temperature for that room. So it circulates the air in the space to maintain that sensible temperature that you or I are comfortable with. The person in the room next to me may want it a different temperature. That unit is going to maintain a different temperature depending on set point, right? But then fresh outdoor air is actually delivered in a different manner to that space. It could be through the corridor. It could be ducted directly into that space. That's dehumidified, so we're comfortable from a humidity standpoint, while that terminal unit is taking care of the sensible load in the space. So that's typically how you're going to see that system design. And again, that air handling unit can be paired with many different systems like a VRF or a chiller boiler system, things of that nature.
It makes sense. You can see how separating the latent from the sensible loads would make sense in the system overall. One trend we're seeing is decarbonization and the electrification of heating and cooling. And so the buzzword of the day is heat pumps. Mm-hmm. So how do heat pumps in rooftop units or in DOAS systems, how are they impacted by this, by the effort? Is there something you need to do above and beyond when it comes to DOAS units if you're running with heat pumps?
Yeah, I mean, decarbonization is definitely a growing trend. Heat pumps are very highly used with DOAS equipment. It's definitely very different from a DOAS standpoint than maybe a traditional like VRF system, right? So, like I said, VRF utilizes a heat pump technology. There you're recirculating air within the space, right, to maintain sensible loads. With a DOAS unit, you're bringing in 100% fresh outside air that is full of humidity. So that is very different from that standpoint. Operating in the heating mode of operation, you have to worry about defrost. Again, you're bringing in fresh outside air versus recirculating air. So those conditions are very different entering a DOAS unit. There's definitely increasing trends of heat pumps utilized for outdoor equipment as well. Local codes, regulations are now enforcing them. They're requiring the operation of those heat pumps at different levels or different percentages. So making sure that we can operate the heat pump well and efficiently with our outdoor equipment is definitely something we continue to explore with that technology. We do offer a heat pump with our units. We definitely have seen a growing trend in the heat pump being utilized across different markets, especially the ones that are requiring them per code. So we certainly expect this to continue. Many large companies, local jurisdictions, states, even countries have made declarations of the net zero carbon emission goals. So it's certainly something we continue to invest in enhancing the technology as it's being utilized more and more with outside air equipment.
So for sure, decarbonization and electrification and energy savings is a big factor, but something I think that we've all become a lot more sensitive to over the last few years, especially as we're coming out of this COVID-19 pandemic, is indoor air quality, right? We all know how the COVID has been spreading, right? And it's all airborne. So that's really jumped as a topic for the day. So first, maybe, can you define what we mean within our industry when we talk about indoor air quality? Is it just about capturing dirt and germs and that kind of stuff in the air, or is there something more to it? And then why is it so important, and what role do DOAS units and rooftop units play in improving indoor air quality?
I mean, like it or not, we all spend a ton of time inside, right? Throughout our entire life. Without proper ventilation air distribution through the entire building, the air we breathe can be compromised and contaminated and sometimes even dangerous. You think about classroom of children, one of them sick, they sneeze, those germs spread throughout the entire air through that space. So trying to make sure that we have high indoor air quality involves making sure that we have ventilation rates that allow for proper air turnover within these buildings so that that contaminated air is expelled from the building and we bring more fresh air in. It really prevents what everyone's talked about in past history called sick building syndrome by continuing to bring in that fresh air and exhausting any air that's already been contaminated. DOAS units allow for direct measurement of ventilation air supplied to the space because it is 100% outside air. So you know exactly what you're getting with a DOAS piece of equipment. You know you're delivering the correct amount of outside air. That's an acceptable ventilation rate for that space or building. The other piece that goes into it is making sure you have proper filtration, like MERV 13 filters, having exhaust fans to be able to exhaust that stale air out of the space and ensure that proper indoor air quality.
Mm-hmm. So it seems DOAS is really playing two really important roles here when we look at the building design. So we're talking about separating latent from sensible cooling. So basically really supporting the building and energy efficiency. And then we're talking about improving indoor air quality. Can you talk about why the demand for these systems has really gone up then, in these past years? Is it driven more, you think, by the need for energy efficiency? Is it driven by indoor air quality? Where are you seeing the biggest demand now for DOAS units?
I would say definitely both. Both are very important. There's certainly been an increase in the demand for high indoor air quality, as we talked about with the COVID-19 pandemic. Everyone is very much aware of higher ventilation air rates are definitely the number one guideline that have been issued. So we definitely want to be providing higher indoor air quality, but at the same time, we want to be as efficient as possible when doing so. So we kind of have this draw against each other, though, because delivering more fresh air to a space drives higher energy usage because you need to temper and dehumidify higher volumes of air at that point if you want to improve your indoor air quality, increasing your energy costs. So it becomes even more important if we're going to increase indoor air quality to simultaneously increase our energy efficiency so we can try and offset that added cost of increasing our indoor air quality or ventilation rates or even lower them. So, recently the Department of Energy requirements have increased from an energy efficiency standpoint as well. Standard traditional RTUs efficiencies have gone up 10 to 20%. Department of Energy is now going to be regulating new efficiencies for DOAS equipments called ISMRE 2. That's coming in within the next year. So there's certainly a high demand for increased energy efficiency along with this demand for higher indoor air quality and ventilation rates for the space.
Okay. So yeah, I like it. All of the above, right? Everything's important. Yeah. So you mentioned there's some legislative changes that have come to the efficiency side of the equation, but ASHRAE's also updated their ventilation and IAQ standards in 2022, right, for commercial and residential buildings. Can you talk a little bit about what these standards mean for HVAC systems and how do DOAS and rooftop units, how are they evaluating to meet these higher expectations?
Yeah, so ASHRAE gives design methods to determine what the minimum ventilation rate needs are for a given space, again, depending on occupancy, size of space, right? Those are what they deem to be acceptable indoor air quality levels. Based on different tests and studies they're doing, vetting out what that minimum acceptable rate is. Keep in mind, that's just a minimum. Delivering more air is just a balance of the cost of energy to do so. But I think we can all agree that delivering more outside air definitely has its indoor air quality benefits. So if you think about your home, for example, if it's been a super long, extended, hot and humid summer, or it's been a really cold winter, like it is here in Wisconsin, we love nothing more than to open up our windows and bring that fresh outdoor air into our space and really clean out that space that's been buttoned up because of that hot, humid weather or that really cold weather. So we all feel that comfort when it comes to bringing in more outside air. So ASHRAE is giving guidelines around how much air needs to be delivered to those spaces that's acceptable. Again, rising above that is definitely needs to be offset with your energy needs and requirements for the space.
So they're setting some minimum standards, yeah.
Right. And ASHRAE even goes further and they say, yes, we need these ventilation rates, and we understand obviously there's energy required to do so. They're also advising around utilizing energy recovery to reduce those energy costs. So by using energy recovery devices, they're offsetting those added costs for delivering more fresh outside air.
Right. And I guess that's pretty typical in a DOAS unit is to have some kind of energy recovery.
Yes, it's very common, especially it actually breaks it out where you are located within the United States. So if you're in a
Right.
hot, humid climate, you can benefit significantly from utilizing energy recovery. If you're in more mild conditions and you don't have high humidity, those requirements will look a little bit different of where you need to be using energy recovery in that.
Right. Yeah, that seems to make sense. So if we look now when it comes to the install, right, recent McKinsey report says 80% of the buildings that are going to exist in 2050 are already here today. So if we're going to improve IAQ, if we're going to improve energy efficiency, we have to do it with the building stock that's already there. What are some of the challenges to installing a DOAS unit in an existing building, and how can we overcome those?
For existing buildings and retrofits, there's definitely many challenges that have to be overcome. Some may be dealing with the existing structure. Can it handle the weight limitations of the equipment? Are you trying to fix some other issue or problem you've had with that equipment? For example, were you having humidity issues before? So you may have to size your load requirements higher. With existing ductwork, you have to configure your units differently to be able to connect to what ductwork exists. Electrical, you have to make sure your electrical loads can handle whatever new equipment you're bringing in. So there's a lot of different pieces that come into play when dealing with buildings with retrofits. But many manufacturers provide flexibility in the different housing sizes they offer, different heating and cooling features, different ducting options, whether it's side and bottom configurations for being able to connect your existing ductwork to the building. So depending on the varying needs of the building, there's a lot of different ways to look at how you can make a retrofit work. So many obstacles to try and achieve your outcome, but you can definitely find many different ways to fit the needs of the existing building.
So nothing insurmountable, right? I mean, if there's the need, then there should be solutions out there, right?
Yeah, many of our outside air equipment is going on retrofits or existing buildings today. So it's definitely something that manufacturers recognize is a need. So you're definitely catering to that type of application of our equipment.
Good to hear. So now, how about on the technology side? Are there some new technologies coming to market that are helping improve DOAS or rooftop units, making them more viable in different systems?
Especially looking at the refrigeration system of DOAS units, standard rooftop units, there's definitely newer technologies that are being utilized to improve the overall unit design. So in particular, when I think of that system, inverter compressors, EC, electronically commutated condenser fans, microchannel coils, those are all technologies that are being utilized that are newer technologies that have provided significant benefits to that overall system, especially from an efficiency standpoint. So, particularly in the past 2 years, we've upgraded all of our systems to provide inverter compressors, microchannel coils, EC condenser fans as standard with our outside air equipment to improve the overall efficiency and just the overall control to provide tight temperature and humidity control for that space. So some of the benefits we've gained from those, we've reduced the weight of our units quite significantly. So we just talked about retrofits, right? And structural design, making sure that we're as light as we possibly can. That helps with reducing the weight of these components. So that was a big benefit of incorporating some of these technologies. When you think of particularly the microchannel coils, that has allowed us to reduce our weight by up to 15% for our overall equipment because that coil is so much smaller and can deliver the same amount of capacity and improves our efficiency. And on top of it, reduces the amount of refrigerant that we're needing to utilize to achieve the same capacity. We're able to reduce that overall weight of that unit significantly.
Right.
So lots of benefits coming from these new technologies, not just from an efficiency standpoint, although efficiency is the number one driver for these changes. We have some other added benefits from making changes to these newer technologies because they've ultimately allowed us to increase our part load efficiencies by up to 50% versus typical designs before of digital compressors, on-off condensing fans, and a fin and tube coil design.
Wow. Okay. 50%. Yeah. Very impressive.
Hmm.
So now talking about the microchannel, nice segue, because one benefit is absolutely the reduced holdup charge on the refrigerant. And we know that here in the U.S., we're transitioning away from the current HFCs and moving more towards A2L refrigerants. And maybe in a chiller where it's sitting outside or up on a roof, it's not a huge issue. But for sure, if you've got an A2L in the system and then you're running air across the coils, could be something that the industry is looking at. So what can the industry expect from DOAS and rooftop units as we move towards A2L refrigerants?
With packaged rooftops and DOAS units, I mean, it's a pretty significant change. It's requiring some significant investment with us, with our partnership with our suppliers, and making sure that there's proper testing and vetting of the change to the new refrigerant. So the new refrigerant, it definitely plays effect with our equipment, right? So it's going to affect capacities and efficiencies, but we do expect the overall DX system design to stay pretty similar to what it looks like today. But instead of utilizing, our particular device, we'll just be substituting that with a device, a different compressor model or coil that allows for that new refrigerant to be compatible with. From that standpoint, yes, you'll see some changes from capacity efficiencies, but overall system design shouldn't be significant changes. Some of the bigger changes, though, are just overall safety and handling of the A2L refrigerant. So the refrigerant goes from a non-flammable to a slightly flammable refrigerant. That's requiring actually a new safety standard for our equipment. So packaged equipment dehumidifiers utilize UL 1995 safety standard. That is now changing over actually by 2024 to a UL 60335 safety standard, and it encompasses the safety requirements for changing to an A2L refrigerant. So there's a lot of work going into not only updating to the new refrigerant, but updating to that new safety standard as well.
Right. Yeah, it makes sense. And that's -2-40, if I remember, for the air conditioning side, right? So I think we're all growing very familiar with those standards. So the A2Ls on the coils, it seems not such a big issue. Now, if we talk about getting back to the variable speed, so you mentioned already that all your DOAS today are running with variable speed compressors, microchannel, and so on. Do you see that uptake also with rooftops, or is it really dedicated just to the DOAS side, or how's that technology getting into other products?
Variable speed technology is definitely increasing. I think overall, when you look at just codes, regulations, there's been increases in efficiencies over the past few years. Inverter variable speed compressor technology helps get you there and exceed those. And I know already they're looking at, we just updated two new efficiencies in 2023. A new one's coming for DOAS equipment here in the next year. They're already looking at the next new efficiency targets for 2029, right? So being able to migrate to this technology that provides you the highest efficiency gain, variable speed compressors do just that. And they allow you to be able to react quickly to different loads that can be variable with outside air coming into your space. So every day, the weather outside is different. That technology has to be able to react to provide tight temperature and humidity control. But the technology's biggest advantage, too, is that it can increase that energy efficiency. It's a technology that takes a step in the direction of not just providing tight temp and humidity control, but providing an energy efficient option as well.
Yeah, and especially, as you said, with the DOAS, when you've got 100% air coming in at who knows what temperatures and humidity levels, to being able to modulate like that is really a big deal, right? It's a lot easier than trying to go on-off and so on.
Yeah, and that technology actually also provides a huge sound benefit too. So instead of loading and unloading or having a stage compressor coming on and off, it's modulating off of a drive. That frequency isn't even really heard from you or I. It greatly reduces the sound level coming from that equipment as well. So another advantage of that variable speed technology.
We talked about a couple different technologies about, you said ECM motors, variable speed compressors, microchannel heat exchangers. Do you see any barriers to these new technologies and having them become a lot more widespread, or how do you see that going forward?
Some of the barriers or concerns people likely have are more driven just by familiarity because it's something new. People aren't as familiar with how they operate. They might be a little bit skeptical of the unknown, right? Something new is a little bit scary. It may seem like the technology is a bit complex, but the fact is that improving efficiencies continue to be of super high importance for the industry, and codes and regulations are driving that. Federal mandates by, the Department of Energy are driving that. Taking the next step in efficiency helps drive those superior controls that monitor, like the inverter compressor, monitoring the compressor envelope, making sure it's operating at its highest efficiency possible, maintaining proper oil return. It's a very sophisticated technology that people shouldn't be afraid of. They should be embracing this new superior technology that gives them more efficiency, and that has been profoundly tested, and it's been utilized in the market for well over a decade now. So it's become more adopted, I would say, because the efficiency mandate requirements and increases from those technologies have been around for a long time, and we've learned a lot over the last decade to feel confident in those new technologies and comfortable that they're going to be reliable features for this type of equipment.
So we've talked about energy efficiency. We've talked about indoor air quality. Are there other trends in DOAS equipment that our listeners might be interested in, or something else you'd like to share?
Yeah, so we talked about it briefly with inverter compressors, but sound is certainly a topic we hear about more often. You had mentioned it briefly about utilizing existing buildings. Some areas of the country are very densely populated. You may have an adjacent building to you. Rooftop units can provide a lot of negative sound that people don't want to hear that unit running and operating. They want it to be very quiet. If it's next to an adjacent building or if it's on a roof, maybe over a space where people are occupying, they want that technology to be very quiet. So the technologies that we've implemented, like inverter compressors, reduce the sound level. The EC condenser fans slowing down the rate at which those fans are operating also reduces the sound level. We also utilize different fan blade designs to reduce the sound level penetrating off those condenser fans. That significantly is reduced as well in part low conditions. We'll insulate the base of our units to prevent sound penetration, right? So that's another topic or area that people do have concern over. And these new technologies just help reduce the overall sound levels coming from this type of equipment.
Yeah, that's a real good point. I guess sound, it's one of those things that till you have that droning sitting over your head, you don't think about it. You always think about your energy bill, right? You think about the air quality, but sound is one of those things that it's great that people like Greenheck are thinking about it so that we don't have to have it sitting over our heads like that. Maybe one last topic, not such a fun one, right? That remiss, though, not to mention the supply chain issues that we and I think lots of other markets have been going through, right, since this pandemic has hit. Do you want to maybe talk about what's being done here to address lead times these days?
Sure, absolutely. So in 2021, like it or not, many of us were impacted by supply chain shortages. We have had similar issues in that time frame. We had to reduce our output during that time frame, but we learned a lot. We've developed new warehousing, procurement strategies to offset those shortages, and it's drastically impacted just how we approach material management. And we've put significant focus in that area. And over the last year in 2022, we were able to increase our output, and we've been actually adding additional plants and equipment to exceed our current demand. So we're back to expanding and growing confidently with being able to manage through all those changes we've had to make to maintain our material through some of the supply chain shortages we experienced in 21. So we feel really confident today and are continuing to grow just with what we have set in place with maintaining our materials.
Yeah, I think we all had a good 12, 18 months of headaches there. So it's nice to see maybe some light coming at the end of the tunnel here. So any last issues or insights you'd like to share maybe with our listeners before we wrap up?
Yeah, I mean, obviously, DOAS and rooftop equipment, I mean, it just continues to evolve. We have a lot of focus on delivering fresh outside air, just with everything that everyone has gone through with COVID in the last year, maintaining high indoor air quality. We're just trying to provide great options for engineers to design with our pieces of equipment that give you that superior energy efficiency. And obviously, codes and regulations continue to drive that within this type of equipment. And we continue to look at, different technologies that continue to drive that efficiency, provide environmental benefits that allow for that precise control of this type of equipment. So it's certainly a pleasure to talk through it with all of you and just share with you what's all evolved with this type of equipment. And it's going to continue over the next few years for sure.
Awesome. Yeah, Bethany, thanks for joining us.
Yeah, thank you for having me.
That's it for this episode of EnVisioneering Exchange. I'd like to thank my guest, Bethany Seubert of Greenheck, for joining us. Don't forget to subscribe to EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever you listen to podcasts. Lastly, if you enjoyed this episode, don't forget to rate, review, and share it with your network. Thanks for listening, and talk to you next time.
This podcast is for information purposes only. The views, information, or opinions expressed during the EnVisioneering Exchange podcast series are solely those of the individuals involved and not necessarily represent those of Danfoss LLC and its employees. Danfoss LLC is not responsible and does not verify for accuracy any of the information contained in the podcast series available for listening on this site. This podcast series does not constitute professional advice or services. This podcast, including Danfoss LLC and the producers, disclaim responsibility from any possible adverse effects of information contained herein. Opinions of guests are their own, and Danfoss LLC in this podcast does not endorse or accept responsibility of statements made by guests. This podcast does not make any representations or warranties about the guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. This podcast is available for private, non-commercial use only. You may not edit, modify, or redistribute this podcast. The developers of the EnVisioneering Exchange podcast site assume no liability for any activities in connection with this podcast or for use of this podcast in connection with any other website, computer, or playing device.